Hi, and welcome back. So today we're going to pick up on doing the graphs of the other four trig functions. So this is section 7.5. This whole first page that you have is very important, and I would keep it handy as you're working each problem until you can do these without looking at this paper. So again, you do need to know all this. You're not allowed to have any notes with you, so these, about that. So these all this information on this page is for you to learn, okay? Again, the quicker you learn this, the easier this section and the rest of the sections will be. So here's what I've done for you on this page, okay? So up at the top, you have the amplitude, which we already know is the absolute value of A, and you have the phase shift, negative C over B. Those two things are true for any of your six functions: sine, cosine, tangent, secant, cosecant, and cotangent. So if you're asked to find the amplitude and phase shift, that's what you do for any of the six, okay? And that's kind of where all the similarities end. So then underneath that, I have a graph of just your basic functions: sine of x, cosine of x, tangent of x, cosecant of x, secant, and cotangent, okay? So these are what the graphs look like. So in the last section, we did the first two, sine and cosine. Now they look a little different here because obviously we only did it up to 1, but still remember that your sine graph starts at 0 and then goes up and comes back to 0 at 2 pi. And remember, we did the cosine starts at 1 and then repeats back to 1 at 2 pi, okay? So we did the domain, range, and period of the basic function. So now this is the period of this graph. The formula for period, remember, was 2 pi divided by b. So it depends, but this problem didn't have a b, or b was 1. So these are just the rules for this function, okay? All right, and then today we're going to talk about the tangent, the cosecant, secant, and cotangent. So all of the information here is going to change a little bit. Your domains are no longer all real numbers, and your range sometimes is, sometimes isn't. So every one of these are a little bit different. So underneath the graphs, okay, is a table that tells you how to find any of the things that you're responsible for finding, okay? Now, keep in mind, when you are doing Hawks, you're only going to be asked about the graphs. So I'm going to be again sending you another worksheet for practice so that you can do some of the things that are on here that Hawks does not ask you about. But it is required on your final exam, and it will be asked of you on the test with that other document. So make sure that you're working on those as well. All right, so here's how this works. Here's the information of how to find the period. Okay, so for sine, cosine, cosecant, and secant, the period will be the 2 pi over the absolute value of b. Remember, the periods are always positive. For tangent and cotangent, the period is just pi divided by b. Okay, so different formulas for tangent and cotangent. Your odd-even functions, odd functions are just cosine and secant. I'm sorry, even functions, I think I said odd. Even functions are just cosine and secant, and then odd functions are the other four. So you do need to know which are odd, which are even. The principal cycle, I'm going to put right here, is another way to find asymptotes. Okay. You're always asked about asymptotes on the final exam. So these are the formulas to find that. So we'll be working on that. So notice the secant and the tangent have the same formula for asymptotes or the principal cycle, and then cosecant and cotangent have the same. Okay. All right, domain and range. Now this is just for secant. This is the line for secant. So everything on this top line are the formulas for you to find these things for secant. And the second line, all the formulas for tangent, and then cosecant and cotangent at the bottom. So to find the domain of secant, you're going to do what this says, which is to write down theta can equal, and then you're going to fill in this with the asymptote, which you're going to find from here. And then you always say plus 1/2 of the period. Well, the period, remember, is up here, so you'll have that number as well. And then you always write times k. So the things that you don't have to figure out is this theta can equal, and then that k value. That'll be in every answer that you give. You're going to be filling in the asymptote and half the period. okay? So we're going to do these. So this looks like a lot, and it is, but there's a lot of similarities and a little bit of difference in here. Then the range, remember the range for sine and cosine was just from d minus a to d plus a. Well, here the range is the opposite of that. It's negative infinity to d minus a, and then union d plus a to infinity. And I'll explain that and why that is in just a minute. So for secant and for cosecant, you'll notice that the domain is the same and the range is the same, okay? But they are not the same as far as finding the principal cycle or the asymptotes. So some things are the same and some things are not the same. It depends on what you're looking for. All right, now for tangent, you'll notice for tangent, you're going to have to find the asymptote and the period again. Again, you're going to write theta can equal, and you're always going to have that times k in your answer. You got to figure out these numbers. Okay, and then look at the range for tangent. That's an easy one. The range is all real numbers. And again, the domain and range are the same for tangent and cotangent, but their principal cycles are not the same. So again, some similarities, some not. Okay. Once you know the shapes of these graphs, these kind of make more sense. Okay, so it's just going to be a matter of you practicing, and then you kind of, most of you will then start seeing the pattern in which things go where. Those of you who are not going to do these a lot or not practice a lot, then it's going to be a struggle. So the more you do this, the easier it gets. So I would say just keep practicing. Even if you do the same problems over and over, you're going to just keep practicing. So what I'm going to do for you today, we're going to go through the notes. I'm going to talk about the main graphs, you know, how they show up and what they are. And then we're going to do this kind of stuff, because this to me is harder and you need more help with this. On Hawks, you'll be doing the graphs. So it's a little bit about the transformations, which you already know, and then you can use your calculator to get the shape of the graph. So I don't spend a whole lot of time myself doing the graphing part of it, because all of you will use your calculators. If you have any questions about it, then please let me know. More importantly, you can do this information that's on here, okay? All right, so you keep this page handy, because as you go through, you can refer to it, okay? All right, so how do we get the tangent graph? So we're going to start with tangent. Okay, now I know the graph is already here. Okay, this is what the tangent graph looks like, and these dotted lines are your asymptotes. So we're going to talk about why you have those asymptotes and where they are for tangent, and so we'll kind of get that same graph here. All right, so we know that the tangent is the sine over the cosine. All right, and tangent is undefined when the cosine equals 0. So if you look at the, you've got cosine in the bottom. And we know in math we're not allowed to divide by the cosine, or but divide by 0. So look on your unit circle, grab my unit circle again, and look for where the cosine is 0. I know the cosine is 0 at pi over 2 and at 3 pi over 2. Okay, that's the only places on the unit circle where the cosine value is 0. So I'm going to write that down, pi over 2 and 3 pi over 2. Right? And it keeps going. I mean, we could go 5 pi over 2 will be next, 7 pi over 2. So every time we go around the circle, there'll be more cosines that are equal to 0. But we're just going to go through one rotation here. So that means at pi over 2 and at 3 pi over 2, we will have asymptotes. So remember those dotted lines. Okay. And also at negative pi over 2. And also at, right, so every pi units, I'm going to get another asymptote, because one, that's pi, right? From up here to here, that's half the circle. So that would be pi difference, right? So every pi units, I'm going to get another cosine that's 0. So I got a bunch of asymptotes, right? There's an infinite number of asymptotes that are going to be on this graph. All right, so where are the vertical asymptotes of tangent? Where the cosine equals 0. So everywhere there's a cosine of 0, a bunch of them, I can't get this answer, okay? All right, so when we look at the tangent, okay, the graph of tangent. So I did this wrong. Pi over 2 is here. This is tangent. I forgot the cosine graph was up there. All right. So cosine, let's remember, starts at 1, right, and goes to -1. Okay, so here's your cosine graph. Okay. It keeps going in both directions, right? All right, so the point of graphing the cosine first, I'd use the unit circle, but we see where the cosine equals 0, right? Everywhere it equals 0, so everywhere that it equals 0, that's your asymptotes. Okay, so those dotted lines, because I can't divide by 0. So here, if we look at the graph of tangent, okay, let's look at some other points. So let's look at what happens at 0. So when you do the tangent of 0, the tangent of 0, remember, is y divided by x, sine divided by cosine. So 0 divided by 1 is 0. So the tangent at 0 is 0. And then we're going to look at pi over 4, right in the middle. What happens at the tangent at pi over 4? It's sine divided by cosine. So any number divided by itself is 1. So the tangent of pi over 4 is 1. Let's say 1 is right there. And then let's look at negative pi over 4. Negative pi over 4 would be here. And the tangent would be sine divided by cosine. So -1, because you got the same number, but 1 is negative. Okay, so here's -1. All right, so there is the graph. Looks like that. Kind of curves a little bit. In between that first principal cycle, okay? So when we say a principal cycle, we're talking about principal meaning the main one. So that would be the one closest to 0. So that would be between negative pi over 2 and pi over 2. So if you go back to that first page, okay, you see on tangent, it tells you that the principal cycle is between negative pi over 2 and pi over 2. That's why those numbers are there. That's the main one, okay, the main one. Now, once you find those main ones, then there's tons more asymptotes anywhere. So you can use any asymptote you want, but when the problem asks for the principal cycle, then that is the main one, okay? So the main principal cycle is between negative pi over 2 and pi over 2. Okay? That's the principal cycle for tangent. So in between every other asymptote, the same graph is going to happen. Because remember, it's a cycle and it keeps repeating itself. So over here, we're going to get that same looking graph. Over here, same looking graph. And it will just repeat and repeat and repeat. Okay? So your job is to figure out the principal cycle and be able to pick any other asymptote out. Well, then how do you know where the other asymptotes are? Well, that depends on the period, okay? So you have to figure out the period for tangent. Well, the period for regular tangent, this graph, is just pi. When we get into putting numbers in here, then the period is going to be pi over b. Okay, remember again, on here, for the other 4, sine and cosine and their reciprocals, the period is going to be 2 pi divided by b, but for tangent and cotangent, the period is just pi divided by b. Okay, and the reason that is look at how long it takes for this cycle to repeat. Remember, for sine and cosine, it took 2 pi to go 1 revolution, once around, but look at how far it takes here. It only takes pi, right? Half as long to repeat the same thing. So the period for pi is half the distance as the other ones. Okay. All right. Now the domain. Okay. Remember on the other page, how did we find the domain for tangent? We're going to do theta can equal an asymptote and then plus the period times k. Okay. Well, here are asymptotes. So just pick one of these. It doesn't matter. I usually just pick a positive number, but you can pick either one. So my domain would be theta can equal, pick an asymptote, so pi over 2, plus the period, pi, times k. Okay, you always will write that because what this is saying is that we have lots of asymptotes. Every pi units, we're going to get another asymptote. So this right here is just saying that we're going to take pi and multiply it once, twice, 3 times, 4 times. So k just represents an integer, positive or negative. So that's just telling you that it's an infinite number of asymptotes that we got to take out of the domain, because this is what we're taking out of the domain. Okay, so these are the asymptotes. So here's 1, and then we're going to add the period, because every period, which in this case is pi, every pi units, we're going to get another asymptote. So that's a way in algebra of writing an infinite number of them, because there's no way I could list them all. So we use k to represent all of them, okay? Now the range, this easy one for tangent, is always negative infinity to infinity, because we're using all the y values. Even though we're not using every x value, there's no problem with the y's. So that's kind of the easy one on it. Okay, so that's the information about tangent that we would want you to find. So now we're going to plug in some numbers for a, b, c, and d, and let's see what we get. All right, so this number 2, now we have a, and then we have the b, but again, c and d are 0. Okay, so in this problem, a is 2, b is 4, c and d are 0. So the principal cycle, okay, so here's where things change a little bit. So let me get that other sheet out. So the very first one we did was just the tangent of x. Now you're going to see that part with x in the middle, you know, that part in parentheses. That's what you're going to set between negative pi over 2 and pi over 2. So we've got to solve for x. Okay, so the first one we did up here was just x. So it's whatever is in here goes between these two values. So for this one, I'm going to have to set, I'm going to do the principal cycle over here. It's like I got to get my answer. So I'm going to set between negative pi over 2 and pi over 2, whatever is in here. Okay, so 4x. So remember, the principal cycle here was only because it was already x in there. I didn't have to do anything. But I got to put that whole thing in there. All right, so all I have to do to solve for x then is divide everything by 4. Dividing by 4. So if I divide negative pi over 2 by 4, I get pi over 8. If I divide 4 by 4, there's my x, and this gives me pi over 8. Okay, so this is the principal cycle, okay, which means these are your asymptotes. Okay, all right, your period for tangent is pi over b. Remember, the period is always positive. So in our problem, b is 4, so the period would be pi over 4, not 2 pi over b. Okay? For tangent, it is just pi. All right, now I've got everything I need, so the domain is theta can't equal one of the asymptotes, so I'm just going to, again, I just use the positive one. It doesn't matter if you put negative pi over 8, it's all the same. And then plus the period, pi over 4, times k. Okay, so that is your domain. So you just have to kind of learn the function and the formula, and then you're good to go. And then the range, easy one, always negative infinity to infinity for tangent. All right, let's try the last one, number 3. This problem, a is 1, b, now I'm going to rewrite that because you might not see that. So this is the tangent. What is the number in front of x? That's your b number. Right? X is not part of it. It's a number in front of x. So x over 3 is the same thing as 1/3 x, right? That's exactly what that is. And then minus pi over 20. So your b value is 1/3 and your c value is pi over 20. Okay? No d. D would be 0 still. All right, so let's do the principal cycle over here because we got a little bit of work to do. Okay, so we're going to set what's in the parentheses. You can use this one or this one, doesn't matter. But this is what goes between negative pi over 2 and pi over 2. I'll just do the one that we started with, x over 3 minus pi over 20, and then pi over 2. So you always put what's in the parentheses between negative pi over 2, pi over 2, and then you got to solve. All right, since I've got to add pi over 20 to both sides, I'm going to go ahead and get a common denominator. So the common denominator would be 20. So this is going to be, instead of 1/2, that's going to be 10 pi over 20. Still leave the middle the way it is. And this is positive 10 pi over 20. All right, so now to solve, we're going to add pi over 20 to all three sides. We're going to add pi over 20 here, add pi over 20 here, add pi over 20 here, which is just 1 pi over 20. So if we add 1 pi over 20 here, we're going to get negative 9 pi over 20. If we add pi over 20 to the middle, we're going to get nothing, so that's gone away. And if we add 1 pi over 20 over here, we get 11 pi over 20. Okay? All right, now, solving for x, so to get rid of dividing by 3, we're going to multiply everything by 3. So we're going to multiply this by 3. So negative 9 times 3, that's negative 27 pi over 20. If we multiply this by 3, we have x. And if we multiply this by 3, we get 33 pi over 20. None of those things can be reduced. If you could reduce them, you need to reduce them. That's it. So that's a crazy principal cycle, but that's what it is. Okay? All right. So there's your asymptotes. You can use either one of these when you do your domain in a minute. Now the period for tangent is pi divided by positive b, right? So our b, remember, is 1/3. So pi divided by 1/3. This is important. When you divide, you multiply by the reciprocal. So that would be pi times 3 over 1, which is 3 pi. That is the period. Okay, that's how long it's going to take for this thing to repeat. Remember that 1/3 is going to stretch your graph by 3. Remember, you do the opposite of that. So we're stretching it, so it's going to get longer. So that's why that happens. All right, the phase shift is the same for every problem. Negative c over b. Okay? So the opposite of c, pi over 20, divided by b, which is 1/3. Okay, so just be careful when you divide. You guys get a lot of these wrong just because you're careless with your division. So when you divide, you multiply by the reciprocal, so that's pi over 20 times 3 over 1. So the phase shift is 3 pi over 20. Okay. All right, now your domain. We already have our period and we have an asymptote. So now the domain is pretty straightforward. Theta can't equal an asymptote, 33 pi over 20, plus the period, 3 pi, times k. So there's your domain. Okay, and then last one is always nice for tangent. The range is all real numbers. All right, so that's the information on tangent that you are responsible for. So again, the more you do this, the more you kind of remember how to find the domain, making sure the period is just pi and not 2 pi over b. Okay, things like that. All right, so now we're going to look at cotangent, which is almost identical to tangent. Okay, so let's look at the difference of that. All right, so we're going to do the same thing for cotangent. We'll go through this a little faster now that we've kind of explained everything. So if you look at that front page again, look at your difference between tangent and cotangent. Okay, first difference is your asymptotes are in different places, which we'll talk about in a minute. And the second thing is that instead of the graphs kind of going up from left to right, in between your asymptotes, cotangent comes down from left to right. Okay. The domain and the range you're going to find you are going to find the same way. The difference will be the principal cycle because, again, of the asymptotes changing, but a lot of this will be the same. Okay, the period is still the same. It only takes pi units to get one rotation through. Okay, so a lot of similarities, one little difference. All right, the difference comes from the very beginning because cotangent is cosine divided by sine. Well, that makes a difference because the sine is 0 in different places and the cosine was 0, right? So looking back at the unit circle, on this one now, we're interested in where the sine is 0, which is at 0 and at pi, okay? So now, pi over 2 is okay because I got 1 here. Remember, I'm dividing by the sine now, okay? So this time, let's look at the graph of sine correctly. Remember, the sine starts at 0, goes up, comes back through 0, and then over here. So here's 1, here's -1. So it goes up to 1, down, like that. And then it does the same thing over here. Okay? So everywhere there's a 0 on sine, we can't get an answer. So those are your asymptotes now. Okay? So where does the sine equal 0? You see all the numbers here. So we'll start at 0, pi, 2 pi, right? All of those, and back to the negatives as well. So those are your vertical asymptotes for cotangent. They have to be the same. I'm not allowed to divide by 0. So everywhere there's 0, there's an asymptote. So it's kind of hard to see the asymptote here. There's one at pi, right? There's one at 2 pi, -pi, and so forth. Okay? Lots more asymptotes. Those are the ones that you can see. All right, so the principal cycle of cotangent then, I can't put between -pi over 2 and pi over 2. That's not the principal cycle. For this one, we start at 0 and go to pi. So it's a little bit easier because we don't have those fractions. So we would put whatever is in the parentheses between 0 and pi. That's the principal cycle, and find the rest of it. Now, the same thing with cotangent. If I ask for the cotangent at pi over 2, cotangent is cosine divided by sine. 0 divided by 1 is 0. Okay, and then remember, this does the opposite. So pi over 4, okay, the cotangent is up at 1. And at 3 pi over 4, it's down at -1. So this graph does the opposite, looks like that. And again, it's going to do the same thing within each of your asymptotes, between the asymptotes, okay? So that's your cotangent graph. So it's almost the same. So the only difference is right here, okay? And that's because of where those dotted lines are. Everything else is the same as it was with tangent. So the period is pi over b, and in this case b is 1, so it's just pi. The domain, theta can't equal. Take either asymptote, it doesn't matter. Okay, pi plus the period times k. There's your domain. And then the range is all real numbers. So the only difference between, again, cotangent and tangent is the principal cycle. Okay, because your asymptotes are in a different place. All right, so let's do a couple of these. All right, so again, I need to do a little work, not a lot, but I'll still do my principal cycles over here just so I have the room to work. So this is cotangent. So we're going to put whatever's in the parentheses between 0 and pi. Not -pi over 2 and pi over 2, that's for tangent. Solve this, so to solve for x, we're going to multiply by 4. So 0 times 4 is 0. X over 4 times 4 is x. And pi times 4 is 4 pi. So there's your principal cycle. The period is pi divided by b, positive b. All right, so what is b in your problem? X over 4 is the same thing as 1/4 x, right? That 4 is in the bottom. So b is 1/4. So we're going to do pi divided by 1/4. Again, make sure you multiply by the reciprocal, 4 over 1. So the period is 4 pi. All right, so your domain, theta can equal, take either one of these, 4 pi, plus the period, 4 pi, times k. Okay? So hopefully you're getting the hang of that, because when we do the next two, it's a little different. All right, in the range, easy one, right there. Okay? All right, Number 6, cotangent. A is 1, B is -3, C is pi over 5, still no D. Principal cycle. Come over here. This goes between 0 and pi. Okay. And you got to solve for x. So we're going to subtract pi over 5 from both of these numbers. So 0 minus pi over 5 is negative pi over 5. Leaves you that in the middle. And then pi minus pi over 5. So pi is the same thing as 5 pi over 5. So 5 pi over 5 minus pi over 5 gives you 4 pi over 5. Okay? All right, and now we got to be careful because now we're going to divide everything by -3. Remember, whenever you divide an inequality by a negative number, your inequality is going to change. Okay, so we're going to divide by -3. Divide by -3. That will give you a positive pi over 15. Divide this by -3, you get x. Divide this by -3, you're going to get a negative 4 pi over 15. Okay, all right. So you can write it like that, or if you want to switch it, put the negative over here. And just remember the big part faces x, so that's got to be the same. Either of those is okay. Those are your principal cycles. I'm okay with you leaving it either way. And you're going to be doing this on paper, so either way is fine. These are not going to be on Hawks. All right, so there's your principal cycle. The period is pi divided by the absolute value of b. So this one you got to be careful. So the period is going to be just pi over 3. Right? Oh, periods are always positive. The phase shift, however, is the opposite of c divided by b, whatever b is. So your phase shift is going to be negative pi over 5 divided by -3. So that's going to give you a positive pi over 15. Okay, there's your phase shift. All right, the domain, got your period, got your asymptotes. So you're ready for your domain. Theta can't equal either asymptote plus the period times k. There's your domain, and the range is all real numbers. Okay? All right. So that is cotangent. So think about what's similar and what is different from tangent and cotangent, because those two graphs, obviously they look the same. They're the only two that have a period of pi. Okay? And then what's different about them is the principal cycle. The asymptotes are in a different place. Okay? All right, so I'm going to stop here, make this part 1 of this. We're over a little over 30 minutes. So the part 2 will be the secant and the cosecant graphs. We'll look at the same things. Okay? All right. Let me know if you have any questions.